Hello and welcome to our notes on average rate of change. For our notes today, we're going to be looking at 3.2. In your book, if you are following along, it's actually part of 3.1. I just feel like they are a little bit too different to call them in the same lesson. So to start, I do want you to try this warm-up on your own, just to kind of have a judge to see where you're at. So I would appreciate if you can pause the video right now. Hopefully you did pause the video just to get some practice. So this is what should have happened. Our A value is -1, B is -6, and C is -8. Now, because this is standard form, we do know that our y-intercept is -8 because this is our C value. Because our A value is negative, it opens down, and we can find our axis of symmetry by using that formula x equals -b all over 2a. So x equals negative b all over 2a. And so when we simplify, double negative becomes a positive over -2, and so we get -3. Now don't forget, your axis of symmetry needs to be an equation. To find our vertex, we're going to bring that x value. I'm going to now take my axis of symmetry and plug it in. You want to be very careful with plugging in, especially into your calculator for this type of problem. You should get +1. And just so that way we're kind of reviewing, our domain is -infinity to infinity, and our range, because we're concave down, we're going to be -infinity to the y value of our vertex with the bracket. So let's graph what we got. So our axis of symmetry is at x equals -3. Remember, we use a dashed line for that value. Then I'm going to plot my vertex, which is on that line, -3, 1. I'm also going to graph my y-intercept, which is -8, reflected over, and then my A value is -1, and so my perfect squares become 1, -1, which those are our x-intercepts. You could do more points, and so, but we have enough by just reflecting our y-intercept. And if you wanted to, we would do 2, 4, that would be our next perfect square, which would become 2, -4. So over 2 down 4 is, so that's why we would want more points, because my line's a little off, but it's close enough that I would take. Okay, so that was review of 3.1 graphing standard form. Now what we're going to do is looking at average rate of change. So we're looking at, so rate of change is how a quantity is changing with respect to a change in another quantity. Average rate of change, this is like taking it over time, the change in the value of the dependent variable, let me start again. The change in the value of the dependent variable divided by the change in the value of the independent variable. A lot of science going on. The formula is similar to slope, and you can kind of see it below. The average rate of change of a function f of x from x equals a to x equals b is f of b minus f of a over b minus a. What this really is it's the change in y over your change of x. So we're going to look at it in a couple ways: graphs, tables, and equations. So giving a graph, we're going to be evaluating. So the first thing that you want to do is set up your formula. So we're going to do f of 1 minus f of -4 over 1 minus -4. Now, what we're going to do is we are going to simplify, or actually, oopsies, we're going to find f of a and f of b. So in this case, we're going to find f of -4. So here's -4. You go to your graph. What is that y value? 1. So f of -4 is 1. Now, I'm going to go to x equals 1. Go to my graph. What is that y value? 6. And if you look at the top, that's why we're always looking for a y value, because the top is the change in y over the change of x. So now what we're going to do is we're basically just going to simplify, plug in and simplify. So 6 minus 1 over 1, I'm going to change this to plus 4, just right away. 6 minus 1 is 5. 1 plus 4 is also 5. And so my rate of change is 1. Now, if that's a little confusing, for a moment, I'm going to erase this. If I connected these points with a nice straight line, the slope of that line is 1. That's what average rate of change is. It's the change between two specific points. You don't know what's going on here. You are just looking at exactly this point in time and this point in time. Okay, and that is average rate of change. Let's go on to looking the next page where we're going to be looking at a table. So for this problem, it's very similar, except at looking at a graph. We're going to be looking at a table. I think they're a little bit easier because you just have to know how to read a table. So I'm going to first set up my formula. So f of 3 minus f of 0 all over 3 minus 0. So f of 3, so you got to be careful. So what that means is that is your x value. So that's over here. So what is the y value, the output? 24. All right, I'll color code to help you a little bit. Then f of 0, so that's where x equals 0. What is that output? That, in this case, is 0, oopsies, 3. And so we're going to be subtracting them. And so 24 minus 3 is 21. 3 minus 0 is 3. 21 divided by 3 is 7. And so our change between those just 2 points, if we would graph them, is 7. Okay. I would suggest maybe pausing the video to at least do one of the next 3 problems just to get some practice, or watch along, do A and B, and then try C on your own. Your choice, but here we go. So we're going to do f of 2 minus f of 0 all over 2 minus 0. And so what we get, so f of 2 is negative 3 right here. And then f of 0 is 5. I'm going to just simplify this bottom real quick. 2 minus 0 is 2. Negative 3 minus 5 is negative 8 over 2, which is negative 4. Let's look at the next problem. So f of 4 minus f of 1 all over 4 minus 1. So f of 4 is negative 11 minus f of 1 is 1 all over 4 minus 1. So let's simplify. So negative 11 minus 1 is negative 12. 4 minus 1 is 3. And this gives us negative 4. Our last one, we're going to, again, just take a moment and set the formula up. I promise you it'll make your life a lot nicer, especially because then you can make sure that you're lining up your numbers correctly. So f of 4 is negative 11. F of 3 is negative 7. You want to be very careful with this problem. And then 4 minus 3. Now I'm going to zoom in. So a double negative becomes a positive. So we get negative 11 over 4 minus 3 is 1. So negative 11 plus 7 is negative 4 divided by 1 is just negative 4. So for a moment, I just want you to think, what can we conclude about the function based on the table and A through C? Well, the slopes are all the same. Well, the average rate of change is the same. Oopsies. So it might be linear. However, we cannot confirm this for sure because what it could look like, so this could look, well, it's technically a negative slope, so our line would look like this. That could be our average rate of change. But what could be happening is that on it, it looks like this, and we're just looking at these specific points on the graph. That is something. So you can say, oh, our average rate of change is the same, but we don't know for sure what our graph would look like unless we were given a graph. Okay, next thing we're gonna do is just a little review on evaluating. We saw this in our warm-up in 3.1, and I said if you were struggling, we would keep seeing it. So here is a little review. So whenever we replace a variable, I'm gonna write it down, always use parentheses. I haven't spelled the word parentheses, but I'm pretty sure I spelled it wrong. I don't know. Parentheses is one of the worst words to spell. Anyways, so we're going to have 4 times 3 squared minus 5. Now let's review some math facts. So let's actually show the work for this. So 3 squared is 9, so I'm going to keep that as parentheses, minus 5. Well, 4 times 9 is 36, and 36 minus 5 is 31. And so that's how we can do it without a calculator. Let's do it with our next one. So 4 times negative 2 squared minus 5. Well, because the parentheses are around that negative 2 times negative 2 is positive 4. 4 times 4 is 16, and 16 minus 5 is 11. Now your last one, if you want, you can try plugging it into your calculator, or what I would suggest, try doing the work and then verify with the calculator. 4 times 1 is 4, and 4 minus 5 is negative 1. So always, always, always use parentheses when replacing a variable, especially when using a calculator. So you can use a calculator, just be careful. Ooh, careful. Be very, very, very careful. Okay. So let's go on to the next page. We're just going to be looking at finding the average rate of change when we're just given an equation. So we've seen tables, we've seen graphs, and now we're going to see our last form, which is given the equation. So the first thing you want to do is you want to find f of 2 and f of negative 4. So this is why we reviewed evaluating. So be careful with this problem because there is a negative. So we get 2 squared, negative 2 squared plus 2 times 2 minus 1. Now I do want to go over like the work for this. 2 squared is 4, but it's still negative because that negative is on the outside. And so the final answer for f of negative 2 is negative 1. We can do the same thing, or we're going to plug in negative 4 into our equation. Be very careful when plugging in. I would use a calculator for this one. I like calculators. So we get negative 9. And now what I'm going to do is I'm going to plug everything into my formula. So f of 2 is negative 1. F of negative 4 is negative 9. And then I'm just going to change this really quick to be 2 plus 4 because a double negative is a positive. Just like the above, we would get negative 1 plus 9 over 2 plus 4, which is 6. Negative 1 plus 9 is 8 over 6. And so when we simplify that, we would get 4 over 3. Questions? Hopefully, or no questions. It's not class. Okay. Let's go into our next problem. Okay. I think I did this one wrong. I think I did this wrong. I'm looking at it again. I'm like, I don't think that's right. So 4 squared, negative 4 squared is 16. Minus 8, yeah, there we go, minus 1. So negative 16 minus 8 is negative 24. This is negative 25. See, I caught it this time for all the people who caught all my other mistakes. Let's fix this really quick. So sorry. Okay, so we get negative 25, and that is what I get for not using a calculator. Negative 1 plus 25 over 2 plus 4 is 6. Negative 1 plus 25 is 24 over 6, which is 3. Oh my gosh, what is going on with me today? 4. There's our average rate of change. Whew, finished it. Okay, it is possible to have a fraction as an average rate of change, but this was a positive. So I would suggest maybe do the next one before, but if you don't want to pause the video and try it on your own, this is how we would do it. So I'm going to find f of 3, f of negative 3. Be careful with your negatives here. So 2 times 3 squared plus 4 times 3 plus 1. I'm going to plug in. So what's kind of nice about using a calculator here is I would almost start with the bottom one, plug it into my calculator, and then what's really cool about the blue calculators is that you can just press the arrow up button and then delete the negatives. If you want to know more about we will talk about using your calculator because you're only as good as knowing actually how to use your calculator. So we get 7, so f of 3 is 31, and f of negative 3 is 7. So now that I have that, I'm going to write out my equation, my formula, f of 3 minus f of negative 3 over 3 minus 3. Ooh, 3, this is why we write it out. 3 minus negative 3. And so f of 3 is 31 minus 7 all over, I'm going to make this 3 plus 3. So 31 minus 7 is 24 over 6, which is 4. Ta-da! Okay, last few things we're going to do is just some Algebra 1 review. The reason we're doing this, if you have questions, is because our next couple lessons are very difficult if your foundations for algebra are not very strong. And so that's why we're going to review it right now. So, adding like terms. These should be very straightforward. Like terms, same variable, same exponent. So 2 plus 3 is 5. The variable stays the same. So x plus x is 2x. And then our next one, you can use highlighters to identify your like terms. And so what we end up with, so 4 minus 6 is negative 2x squared. And then 2x plus 1x is 3x. I do want you to write it in standard form. And standard form is where we're in, our exponents are in decreasing order. Okay, so that's adding like terms. Multiplying terms, we multiply the coefficients and we add the exponents. So like 2x times 3x, we do 2 times 3, which is 6. And then x times x, which we're going to see in a moment, is x squared because 1 plus 1 is 2. So the answer for this is 6x squared. Now our next one again is x times x is x squared because when you have an exponent, what it is, it's repeated multiplication. And so that's what's happening there. Our last one we're going to do right here is 4 times 6 times 1, if you really want to write that, which is 24. And then for our exponents, so we have x squared times x, we get 2 plus 2 plus 2 plus 1 to get x equal x to the 5th power. So the final answer for C would be 24x to the 5th power. Okay, now multiplying binomials. There are two ways. You can do box method or FOIL. That's what your parents probably know it as. We also call it double distribution. So I personally love the box method. What it is, it's called the area, also known as the area model. You're finding the area of each box. So I'm going to do x plus 3, that's one binomial, and 2x minus 5. And then the formula for area is length times width. So x times 2x is 2x squared. Well, x times negative 5 is negative 5x. 3 times 2x is 6x. And then our last one is 3 times negative 5 is negative 15. The reason that I like the box method is because most of the time your diagonal will be like terms. And so what we end up with is 2x squared plus x minus 15. That is standard form. Now, if you don't like my box method, double distribution. So that's where you take your first group and you distribute it in a sense. So it's x times 2x minus 5. I'm breaking up, so plus 3 times 2x minus 5. And now I'm just going to distribute and combine like terms. We're going to get the same answer. I just wanted to show you two different ways that you can get the same answer, because sometimes people like the double distribution over the box method. Sometimes people like the double distribution or box method, whatever one you like. They both will get you the same exact answer. So that is multiplying binomials. Let's go to the last page, which is simplifying square roots. So there is a cheat sheet attached to your packet. This is just to see all your perfect squares, so that to kind of help with it. So the reason that is right here, like the square root of 49. 49 is 7 times 7. So that's a factor tree, and then we find pairs. So like that's why the square root of 49 is 7. 24 is not a perfect square, but we can still make a factor tree. So 24 is 6 times 4. There's a bunch of ways that you can show it. 6 is 3 times 2, and 4 is 2 times 2. So I have a pair. I'm going to send it outside. Well, 3 and 2 don't have pairs. So they're going to stay inside and get multiplied together. And so our final answer for this is 2 rad 6. Okay. Our next one, 120. If it ends in a 0, 10 goes into it. So 10 times 12. So 12 is 4 times 3. And 4 is 2 times 2. And 10 is 5 times 2. I know I'm done when the factor tree ends in all primes. I'm going to find my pairs. So the square root of 120 is 2 rad 5 times 2 times 3. Where those are coming from, it's what's not grouped up. Now, I do have this 2 out in front. It's still there, but we're just going to multiply those outside numbers together. And so our final answer for this is 4 rad 5 times 2 is 10. 10 times 3 is 30. So 4 rad 30. Okay, last two, and then you're done. So multiplying radicals. So first I would suggest ask yourself if you can simplify. 5 is prime, so we can't do anything there. 12 is not. 12 is, if you want to do 6 times 2, 6 is 3 times 2. So what we're left with is rad 5 times, look at that, a pair, 2 rad 3. From here, we multiply those outside pieces together, well there's only 2, and the inside pieces together to get 2 rad 15. And that is how you multiply radicals together. Our last one, E, I would suggest maybe pausing it and trying it on your own. I hope you did. Here we go. So 45 is 9 times 5, and 9 is a perfect square. It's 3 times 3, so I've got a pair there. So I'm left with 3 rad 5. 18 is 9 times 2, and 9 is also a perfect square again. And so I get 3 rad 2. So I'm going to multiply these together. And what happens is I multiply my outside pieces together. And then what's inside stays inside and gets multiplied together to get 9 rad 10. Now you do always want to ask yourself, can you keep simplifying that radical? In this case, no, because 10 is 5 times 2 and there's no more pairs. So hopefully the Algebra 1 review was helpful. We will be using a lot of it, and we'll answer questions if you still have them in class. But that is average rate of change. For your questions or things to remember, I would write that formula, which is f of b minus f of a all over b minus a. So far you really have 2 formulas to remember. Come to class with questions.